So we will continue today. Just a quick comment on the example. So our assignment last time, and that's the assignment that you worked on during the class, was to create a function, however you decide to name it, that takes as an input a radius and the number of sides of a polygon and produces an output that gives area of the polygon that has n sides and radius, or rather this radius r is right here, r, perimeter p, and also this length of this side s. Okay? So it's easy problem where you actually have formulas so you can easily just compute. And this was the example of how do you actually organize a function. So let me show one possible design of that function. I'll just walk you through it. So this here, the function name is polygeom function, and it has this funny way of starting as a lowercase and then it has next word as an uppercase. It's part of the design. I guess, so is Eric Hofbauer here? So Eric, what are the input variables here? S and N, and what are the output variables? A and T. So this is slightly different from our assignment. Our assignment had a radius. So that's again part of the design. Do you want the radius or the side length to be an input? Okay. So in this particular case, there was this S and N. So now, what is this first part in green? What is that?
That's like the notes about what the function is and what it's supposed to do.
Right. So how can I actually, when I know that I have a function with a certain name, how can I get those notes printed in MATLAB?
I know you told us that I can't.
Help. So you just say help polygeom, or whatever the name of your function was, and whatever you put in here as a comment, so that's very helpful, no pun intended, because that way you will forget what it is that input was and how do you actually call that function, because in order to call the function, you need to know what input variables to provide, otherwise MATLAB will yell at you, okay? And it will have some error message. And basically, this is a very nice and clean way, so this is a great design, but I'm going to tell you immediately that over the course of your programming, you're not always going to be this clean, but something is better than nothing. So at the very minimum, I would just put this portion, which is here a synopsis, just put this part, okay? Or even just copy this line as part of the comment, so you will immediately know how many inputs and how many outputs, and then just a quick note of what the inputs should be and what the outputs are, okay? This is a very nicely typed up, but it doesn't have to be super nicely typed up. As long as the information is there, that's better than nothing, okay? And then we proceed. So here actually this function computes the radius because side was given. If the radius was given, you would compute the side. So that's again part of the design, or what it is that you needed to solve. And then here actually, instead of just putting in the formula for area, which is basically just n times r squared times sine of p over n, it decided to actually create another function that does that. Okay? And then just calling the function. So A is just area of Rn, and function area basically just computes that area. So this is part of the design. What this does, it creates a cleaner succession here that is easier for a human to read. I will scan over this, and instead of figuring out, what is this formula again? What is that formula for? Now you know. 2 months from now you'll forget. Okay? Oh, it's area. Computes the area. Move on. Computes the perimeter. Move on. Okay? So this is just a part of design that will actually just allow you to read your code easier. It is actually, the code itself is actually faster without creating a new function. Okay? So just putting this line actually here and this line over here, that creates slightly faster code, but again, many times that's not the trade-off you're looking for. You're looking for something that somebody will be able to use or go into the code 3 years from there. So that's part of it. So again, And then these functions that you design within the file that are second and third function in one file, they're called sub-functions or secondary functions, and they typically cannot be used outside of this scope of this file. So I cannot call them from the outside. The only one I call is that polygeom. So if I want to kind of hide certain things and just have them in the same file, I would create sub-functions here. So again, this is just an alternative way and a little more advanced than probably what you did in class last time. Yes?
When I was creating sub-functions for the assignment, it would tab the function out like halfway, not like third of the way.
Those are for readability.
Okay, but like when I did the one for the perimeter, it would put it as if it was a sub-function of area. Is that like a problem?
It's not a problem. It probably does that automatically. One thing that you could possibly put in to avoid that is put end here, end here, end here. Okay, so 3 ends. So ends are somewhat optional. MATLAB will survive without them, but I would say that it's actually a good programming practice to put them in, just so you know that it's a function that ends here, function that ends here. So in part of the function syntax, you could put an end to point out the end of the function. Yes.
So about applications of end, if we had put an end after each function, making them no longer sub-functions,
they are still sub-functions. The moment you have a second time you introduce function, that's a sub-function.
even if we've closed the original function.
Yes.
So we still wouldn't be able to call it.
Yeah.
And if we had put area and perimeter each as their own whole function
Files,
in a
then you
different
can
tab,
use them in some other file.
could we call them from the original polygeom function?
Yes, of course. The moment if they're in the same folder, that would be immediate. If you decide to put them in a different folder, you would have to add that folder to the path that MATLAB knows to search for.
So there would be no difference between this and putting area and perimeter in their own file.
So it's just a part of your design. How do you want to organize things so they're more readable to you? Yes. Any other questions? All right. So now we will actually switch to stuff that is a little more advanced in the slides, and those are for loops because they're called for in your homework. So I want to pay a little more attention to those, and I do hope that this did not freeze in the meantime. Okay. If I can actually make this thing communicate with me. And apparently I cannot. Oh, great. Let's try again. Okay. Can I just hear? Huh. Technology is failing me. And I'm not sure what's new other than new operating system. Alright, I will work without it. So what we will actually try to compute here, I will open a file instead that has a printout of what I need, so it's visible. Oh well, I'm just gonna type it in. Alright. So let's say that we have an assignment to insert. Okay. So let's say that I want to do a sum, and that sum is going from, actually I need this one. so that sum is going for I is equal to 1 to n, and x I that's hilarious. Okay. xi, and let's actually do it a little more interesting, xi squared. Apparently it doesn't want to delete this first sum. Alright, so this is the sum that I'm trying to compute. Okay. That is almost there. Okay. I wish I was writing. So this symbol, sum, says start over whatever indices are indicated here. So I'm looping over I that goes from 1 to n and sum things up. These things up. This is assuming I have a vector x that has n elements, x1, x2, x3, and so forth over to a. So let's assume that this is something that I have. Let's now assume that, for instance, I actually have, I'm improvising here without my writing pad and trying to be projected on the screen. So let's say that I have n is equal to 3. And I have vector x. So this sum, I'm going to call it S, is equal to, is David Hoon here? So, am I butchering your last name completely?
It's
Huh?
Win.
Win, okay. So H is silent.
Yeah.
Okay. So if I have basically n is equal to 3, what is this sum equal to? How would you compute it? Let's say that your x, I'm going to give you a vector x. So vector x is 1, 2, 3. I'm not very imaginative here. So the sum is equal to, so x1, what is x1? 1. So 1 squared, right? Plus 2 squared plus 3 squared. Right? So it's 1 squared. I'm gonna do 3 squared plus 2 squared. Oh, I'm gonna repeat. So this is where my handwriting would be much speedier. Okay. So if I was in MATLAB, that I'm gonna start in a moment, it would be a simple thing to type that in and compute. Now this is easy if I have a vector of size 3. Now if I change that to 300, let's say that we have a vector of production over time, right? And I want to basically do cumulative production, and for some reason I want the square of it, some unknown mathematical reason. Okay? But, or maybe I just want to sum up all of the elements, and I have 300 elements. Is that something that I'll be typing into my calculator and summing up one by one? So we need an efficient way to actually sum all of those up, however elements I might have in my large array, and repeat that loop and do it. So we were essentially going to do just that in MATLAB. So I'm going to open a script and do it in a script for now. So basically I'm going to do new script. And I'm going to give myself a vector x. Okay? So I'm going to, next person, Santosh. Santosh here? Santosh is not here. Jacob, I already asked something last time. Taylor? So, could you give me a vector with 300 elements, however it is that you want to come up with that vector? We had some functions that we designed. How would I create a vector 1 through 300? Parentheses, you said? Mm-hmm. Linspace, yeah. Good. How would you tell linspace to actually have 300 in there? 300. Right? So this is one way. I could have said, so these are now options that I could use with built-in functions. I could have just done this. Okay, that would work. I could have said, well, I don't want this beauty 1, 2, 3, 4. That's too pretty. Let's actually do something random. Right? I could, now let me see if, Siavash, so can you scale this random gives out output between 0 and 1, right? How would I scale that to 4 to 5?
4 to 5, multiply it by 5.
Then it's between 0 and 5.
Add 4. Yeah.
Add 4. So if I add 4, then my smallest number will be 4, my largest number will be 9.
No, I mean take away the multiply by 5.
Yep. Okay. So it's essentially, if I want things between 4 and 5, it's this, right? So I'm taking the smallest number plus whatever the difference is times the result that is between 0 and 1, and that's going to scale my numbers between 4 and 5 in this particular case.
You also do it right at the beginning of your parentheses, do brackets, and do 4 comma negative, or 4 space negative, 4 space 5, and then bracket, and then comma after.
I could, but then it's not random. I want randomized number, like ugly numbers. Yeah. So yes, it would still give a result that is between 4 and 5, but it would be ordered as opposed to disordered over here. So these are some ways to create a vector. It doesn't really matter, so this is just multiple ways to create myself a vector. Now I want to actually compute the sum of squares in this vector, whatever the vector is. I need two things whenever I'm actually doing anything computing. I can't just have sum hanging sum from 1 to n, right, of some vector x. I have to actually have concrete things. So first concrete thing within here is we define the vector. Okay. Second thing, I'm computing sum, and I'm not into typing in x1, like I cannot just start doing this. X, my sum is equal to x of 1 squared plus x of 1, 2 squared plus all the way, right, to 300, because I'd be sitting here typing all day. That's not what we want to do. So for computer, actually, all programming languages have something called a loop, a for loop, that will actually instruct the computer to go from however many steps, step 1 to step 300, and do something in the process. So in order to compute the sum that way, we're actually going to start or initialize the sum. So this is initialize sum. Okay? And I'm going to call it S. And then I'm going to say, computer, for I is my counter. That's something that is going to count the steps. For I is 1 to n, or 300 in this case. Do something, and this is just end of this for loop. So in order to compute this sum, at every step I, I'm going to grab element x of I. In this case, I need to square it and add it to the sum. So what I'm going to do is I'm going to do S is S plus x of I squared. So the way this sum executes, it's going to start from I is equal to 1, okay? And then it's going to say, aha, S, which is currently 0, initially it's 0, so that's why I have to have it defined. It's going to be 0 plus x of 1 squared. Okay? Then it's going to come to an end and go back to the for loop and see, well, how is my I doing? Am I still in the loop? I am. My next one is 2. Okay? So for x is equal to 2, I'm going to take my old sum S, which is x of 1 squared, and add the next number to it, x of 2, because I is now equal to 2. Okay? And then I'm going to keep looping until I get to 300. Now let's actually execute this just from 1 to 3, just to see. And I'm actually going to display my I. And I'm just going to say I here. And I'm going to say S. And I'm going to remove the semicolon so it actually prints. And I'm going to actually go and define this as a pretty numbers just so that we see a little better. Okay? So I'm going to save this. I need a title, so I'm going to say sum squares of squares. And I can actually run it from here, or I can type it from here. I'm old school. I like typing things. Or not, I don't like, I'm just trained to do it. Okay. So when we execute, we see that for every, first my I was 1, and my initial sum was 1. Okay. Then I went to the second step of the loop, I is 2. My next thing is 1 plus 2 squared, which is 1 plus 4, that is 5. And then for 3, I added 9 to it, and I got 14 as the final answer. And my S now is 14. Yes?
Had you not put counter in the loop, would it still have increased?
No, you have to tell, in for loop, you have to give it a counter.
I mean, had you not made it output, had you just had counter?
Oh yes, this was just to print what it is, so that you see that it really is changing that way. Yes?
How did you display that?
Hmm?
How did you display that?
How did I display? I just typed in I. That's it. Now I can make a pretty input and output, and we are going to introduce a couple of things to make this pretty. So I'm going to say display computing sum of squared vector elements. So I'm just putting a pretty comment saying what I'm doing. Okay, so that's display. So that just displays. Displays, this DISP just displays the text. I can say hello. And it's going to display hello.
If in the function you had semicolons in the for loop,
Then it wouldn't print, but it would still
it would
execute.
still, it would just
Oh, yeah.
store it, right? Okay.
Yeah, so it would just do things silently, okay? So I'm going to suppress this output S, but I can actually say display, or if I want actually to print this variable I, okay, I cannot say display of I need to do formatted output. So I'm going to say fprintf, that's formatted print to a file, and in this case to a command line. So formatted print, I'm just going to say step I is equal to. So this is what going to be the text that it's going to print. And then I'm going to say tell it to print the variable, the current variable I, which is an integer. Integer is %d. So the moment I put %d, it knows to wait for a variable after this. There's some variable other than text. And this variable is I, and it's an integer. That's why we're displaying it as %d. And I need a comma here. Okay. And I could have then actually, I could do this formatted output here, and I'm going to step I in partial sum S is, and this could be a real number, so I'm actually going to put F as a real number, S. Real number, of course, can have decimal points that integer doesn't. So I have just introduced a formatted output command, fprintf, and this is very useful in displaying the results nicely. Yes? For loop. What about it?
Why is the F there? Can it just be with this I by itself?
No, then you would just do, well, you could in this particular case, but I'm just assuming that whatever I have is in some vector x. Okay. So yes, a good point. My x is actually going from 1 through 300, just like my counter I, if I actually had 300 here. So I could have just done I squared here. But I could have changed my x to random input, and I still want this loop to work in that case. So let's actually do that. I'm going to change my x to, so I'm going to comment these two. And my x will be now some random numbers. Okay? In which case I need to do x of I squared. So let's just execute this 3 times. And remember, before I execute, computer does only what you tell it to. So this printout is actually going to be slightly ugly because we are telling it to be ugly. Let's execute. What did it do? Step for I is equal to 1, step I is equal to 1, partial sum S is 23.1 something. Okay? And then it started the text again. That's precisely what I told it to. The step 2, it just kept writing. Okay? So I would like to do a mixed line, right? For a little nicer output. And the way we do that is there is a special character here, /n, sends things to next line. Okay. So now when I execute again, I'm actually going to have each of those lines or each of those information pieces printed in a separate line. So this is how my loop, how my S, these partial sums graph. Okay. Now if I execute this, yes?
Oh, so you use percentage D and F, that's a bit different.
Yes. Integer, real number.
And what is the backward slash n do again?
That is a special designated set of characters that will send things to next line.
Oh,
Okay. So it's actually a command. Go to next line.
Okay.
So this is basically go to. Okay? This slash. Whereas this percentage says expect a variable to be substituted here.
okay.
And the rest is just verbatim text.
So the I will be substituted for the percent
Yes,
D.
for percentage D, and S will be substituted for percentage F. And I'm telling it how to format that variable. Now I could be a little, just one more point, I could be a little more specific. So F is a real number, so it could have decimal points, okay? And those decimal points are how many to put. I could put something like 2.2. So leave 2 spaces before the dot and 2 spaces after the dot, essentially. So if I execute that, then I'm going to have a little nicer thing to look at. Though granted, so I should have more spaces here. Any other questions?
So since we're doing random, shouldn't the sum of everyone be different?
You actually have to restart what's called the random seed, otherwise it's going to always actually start from the same. Okay. So actually, I temporarily forgot how to do it. So point he's making, okay, so this is supposedly random, and every time I execute, I'm getting the same numbers essentially, right? And that's kind of wrong. So basically, let me help rand. So somewhere in help rand would be how to do, what is RNG? Okay. This is, I think RNG shuffle should do it. Let's try. So before we do this, we kind of shuffle the deck, you could say. Let's see. So this is deck shuffled. Yep. Okay. So shuffle, this basically forces restarting the or reshuffling the start seed of the random number generator. Otherwise, it'll be constantly, every time you execute, you're going to get similar result. So remember this in geostatistics when you take it. You will probably have to have 10,000 realizations of some large field, so you'll have to shuffle the deck 10,000 times. Otherwise, you'll be constantly getting the same output. Okay? So just the formatted output, so basically now, okay, so now we basically tested how things work. Okay? From 1 to 3, we printed things out. Printing is actually part of debugging process, okay, and beating out errors in your code. So now that we think, oh, this works correctly, now I can actually execute it 300 times. I don't know that I want this output 300 times because it's going to actually put things, so I'm going to comment it here, and I'm just going to say, okay, I'm going to just report at the end number of elements that it summed up and final sum. Okay? And this might be a larger number, so I'm going to allow for at least 5 decimal places. So this is sort of leave 5 spaces before the dot. So basically, I then just get a final report. Questions? And actually, I'm going to clear. So clear clears the variables, and I'm going to say CLC, that kind of cleans the space here. So now I'm going to execute.
Question, could you repeat again why you put the 5.2, the 2.2?
Just to leave more spaces. It's still, even if I put 2, it's going to squeeze them in, but just like indicates that there might be more spaces here. With the dot, it's 5.
Okay.
That's all. And 2 after the dot. And one more nice thing is I'm going to put a space after this so that actually this command line actually jumps into the next line. So this is now being picky, which I am on Wednesday. Not so much on other days. That was a joke. Lame one. So now it actually jumps to the other. The degree of my pickiness depends on the time left till my deadline for submitting whatever it is that I'm working on, right? So I'm much more picky about formatting if I actually have the time to do it. And if I'm rushing to the end just before submitting something, then my pickiness about formatting is not so big. Okay. So this is basically, we learned something how to print things out so we can actually debug our process. In MATLAB, it's actually nice. You can just say I or S and it's going to print it out. But if you do that a lot, then you won't be necessarily knowing what it prints. So you need some human readable text, and formatted output does that for you. Now an assignment for you. So this is a script file, right? Script file is just a bunch of commands that are self-contained, okay, that you can just call. Okay. Now I want you to basically take this for loop and stuff before it and create a function that will be a function of vector x and number of its elements n. So that function will just return this sum. So the function will return this sum of squares for elements 1 through n. So in that same directory, and then you will basically, from this script, instead of computing this, you will call that function. So I'm going to say open or new function, and I'm gonna type in an assignment here. Function that takes vector x and returns and number of elements n, and returns sum of squares of the first n elements of x. Give it a name you'd like. You will need input and output arguments, and basically copy part of that script into a function. So there's no need to type much new in. You've typed everything already, essentially. And I'll walk around and help. There's 3 of us actually available to help. Yeah, so that you copy stuff in. Well, this will actually create x for you inside the function. If you're passing it in, you don't want to override it. So you inside your script, you create x, and then you just pass that x. No, you just in your script, you already created, just leave it there. And this function should just do the operation of something like that. If I comment this x here, where's the script, whatever working. So just leave this part in the script. And here, this is where basically what you take the function, right? And you would from here call that function of x, right? X that you just created. So you can in the script change x as you like. And function is x.
So you're saying that's this out.
Yeah. Because otherwise there's no point of making an input, right? It's not an input, then it's actually a result of your function. Does that make sense? Display, yeah. So copy that into a function. Now, okay, so that actually does something, and it computes S. So S will be returned, so you're actually good there. The only thing that you do is how many elements, because here you're going to put maybe it's this. So here, comma inside. So now we have input one. So how do you actually format those products? Now I need to call that function. So the function is called squares. So we go back to floating point from the outside. Squares. You read it? And you also need input and how many? So you want first 5, you want first 10, you want first 17. So the whole point is that you can now call it however you'd like. From the outside, you can do it for the first 50, 70, there's flexibility.
Right.
And that's what you're creating the function.
So then you
You do? You follow?
Yeah.
You try to create.
So if you don't do that.
You also so I will use the script and then call my change.
So n is the same as the way. No. The next thing we
so basically, I don't want the work that was in the script. I want to functionalize it so I can start change up how I call it. So where's the, did you write the script?
because first term x
It's out of my head. So I had an x that was created. So let's say this is just but that's gonna be now part of the now x input arguments x. And also another and then output will be the same.
So we just create the vector of x, then inside the function.
Actually, there's no sum. So sum x is so now remove this x. So you have to actually repeat the word. This. Yeah, that way. And it's just not going to go too quickly. It's going to go in. And the rest of and that's the whole point. You can be whatever you need it to be. 30, 50, 70.
Oh,
Yeah. That's you use that by actually storing it. So you can also put the call for storing it. There you go. Semicolon. Yeah.
Oh, it is literally. I was acting on my best grade. Yeah, no, me too. And it was like the same test.
Well, one thing is that if you create it within the function, then it sounds really well, for you it's actually awesome, but I want you to create it outside and then possibly.
Okay, so X and N are both.
So just a very quick before we part. So how would I do this? Good old cut, copy, paste. I'm just gonna cut or copy everything from here. My input variables are X and N. Name of the function is sum squares. Okay? And my output is S. In good programming practice, I'm going to copy this as sort of a synopsis of the function. Here, 300 is not now 300, it's a variable. So I'm going to be N. And this is essentially it. Sum of squares. So now I can just say sum of squares x 20 or 30. Oh. Sum squares 10 and so forth. So I can execute it for anything that I want. And that's the flexibility to get to the function that is not there. And I can use it in other scripts and so on. Okay? Huh? I will probably ask you to, yes. All right? See you on Friday. That was for introducing how to print things up. So not in homework, no. Yes, yes. Just for kids.
Can you?
Sure.
It gave me the answer, but it says error.
Take a look. So what is the error? Error in example, output argument sum not assigned. So you actually didn't create sum, you created S. So this should be S.
Oh.
It's telling you output argument is not defined. Something else was defined, right?
Like run.
So
do you have to type in?
Yes. So function you cannot run because it needs input. So you actually have to run it from here, and you have to provide it input.
That has to be.
Yes. That should work.
There we go.
All right.
Okay. All right.
So function you can't just run because it requires things that you. That's the whole point.
So from that, just real quick, I wanted to ask, you just need to have any X already into your workspace, right?
Yes. Yes, you do.
You just don't want it in the function, you want it in your workspace.
That's how I wanted it today.
Okay.
Okay.
Thank you.
Mm-hmm.